Right there, Krazifizix here. We want to summarize all our Euclidean theorems and put it in one piece and in one little quick video. So we're going to use X doctors in Cape Town plus 1. I'd like you to listen effectively. This will put all your theorems in one piece, especially if you're in grade 11 and in grade 12. So let's start with number 1, which is the X. Okay, I'm going to start the numbering. So we have X. And now what are we thinking of when we see an X? Let me make it a bit of a bigger line so that we can see what is really going on. When I see that, I am literally thinking of something here. And I know what you're thinking, even grade 8. So number 1, we're thinking of what? Vertically opposite what? Angles. And obviously we know that if it's a straight line, one of the theorems we need to remember is angles on a straight what? Line. So that is our second thing. Now let's go to the letter D. The letter D actually stands for the word diameter. So if I'm looking at a diameter, what am I looking at? So I have a circle. So anytime I see a diameter, I should actually be thinking of certain things. Let's see what we would be thinking about. All right, so we have the center of the circle, and that proves that that's a diameter. This angle is what? 90 degrees. So number 3, we are thinking of what? Angle in a semi-half circle, and that should be equal to what? 90 degrees. I want to show you something again that you should be thinking of. Number 4, please think of SOHCAHTOA. SOHCAHTOA. And number 5, think of what? Pythagoras. Basically, we are thinking of a right angle triangle. We call it a RAT because it forms a right angle triangle. And I should think about those two things when I see a diameter. All right, let's go to the next one, R. What does R stand for? R stands for radius. Okay, when I see a radius in a circle, I'm going to think about something. The radius in a circle actually comes from the center, and that's the key word that I'm looking for. It comes from the center, and once I see that, I am thinking of something here. All right, what are we thinking about? That becomes our number 6. Remember, that is a radius, and that is another radius. This becomes the centerpiece. And so we're number 5. Number 6, what am I thinking about? Angle at center is equal to 2 times the angle at the circumference, which means if this is X, this is the bigger one, 2X. Now, don't forget, there's something hiding here that I want you to take note of. Look at that. Beautiful. That forms an isosceles triangle such that this angle is now equal to that angle. So that takes me to number 7. When I see a radius and I see angle at the center, I should remember angles opposite equal what? Sides, or angle opposite radii. Very, very important. You see, we are on concept number 7. Beautiful. That's our R. Now let's move on quickly to S. S. The word letter S will stand for the word same. And I want us to look at, there are 3 variations that I want us to look at here. Number 1, okay, let's draw that. Let's draw a circle, not an arc. Beautiful. So we're actually talking about same. And what comes to mind is quickly angles in the same segment. So you would notice, okay, my triangles are going wayward. Beautiful. So this angle here is equal to that angle there. That will be number, what now? Number 8. Number 8. And what would that be? Angles in the same what? Segment. Okay, like I said, we're going to have 3 variations of this. So this is the first one, still looking about same. The second one, let me see if I can squeeze that on this page quickly. All right, our second one would be this. Let's draw a circle. We draw a chord. So I group all of these under one thing. Okay, and I have another chord. There we go. There we go. Now the condition is that this chord will be equal to this chord. It means that the angle subtended by those chords are equal. Let's quickly redo that. Okay, so this line is equal to that line. So you would notice that this is the angle subtended by one chord and another. So I group this, number 9, angles subtended, or equal chord. Let's go the way we remember it. Equal chord subtends equal what? Angles. I'm going to go on with this and variation. Now, our angles are right on the circumference. But let's go on to another variation still under S. Then we go to number 10. Still on the, we have 2 more under this. Okay, so I'm going to quickly draw my circle and mark the center. I want you to look at something here. I'm going to mark the center there. I'm going to draw a chord, and I'm going to draw another chord. Now, this, I need this thing to help me with my straight lines. Okay, so I have a chord, okay, and I have another chord. But this chord are producing angles that go to the center of the circle. Check that. Okay, the condition again would be that this and this are equal. But look at, they are coming to the center. We are going to go to number 10. I hope you're making a list of this and say equal chord subtends equal angles at center. It's another theorem. Now, the next one, still on the same, because I'm grouping the word same and equal together. Okay, my circle looks like a squashed orange there. Let me do that here. Let's put it here. So I have a circle and I have another circle. Okay, all right, beautiful. And we would mark these circles as equal. Okay, let's quickly draw. Let's draw our chords quickly. Okay, and then we produce that. We produce. So you would see here, these are two distinct circles. But the thing about the circles is we want to make the circles equal. Or we tell you that the radius of the circles are the same. Now, putting a chord here, putting a chord here, they are two different, but these circles are completely congruent. This angle here would be equal to this angle, although the circles are two separate circles. Then we say equal chords in equal circles subtend equal angles. Please take note. The chords are equal, the circles are equal, and one way of telling us that the circles are equal is to say R1 is equal to what? R2, where R is the radius of the circle. So I can do that. I can do that and call them R1 and R2. Let's make it straight. Beautiful. So I have my circle. Okay, this one here. Let's see if we can make it longer. Beautiful. So we have that as the center and that as the center, R1 and what? R2. So there are two circles, but we are saying that the radius of one is the same as the radius of the other, which make my circles equal. Then I have two chords in those circles that are also the same. Equal chords in equal circle subtend equal angles. All of these are grouped under the letter S. So take note, we have fourth concepts under this. Next one, we look at C. Beautiful. What is C? C represents a cyclic quadrilateral. And the examiner is not going to tell you what are the properties of a cyclic chord, as long as the four vertices rest on the circumference of the circle. We can say it's a cyclic chord, except told otherwise, because it is fulfilling the basic properties of a cyclic chord. So don't wait. Don't wait to be told. Okay, where are we? Number 12. Opposite angles of cyclic chord are supplementary, which means they add up to 180 as supplementary. That is, angle A plus angle C equals to 180 degrees. Angle B plus angle D also equals to 180 degrees. Number 13. Now, I could actually produce one of the sides, you see, extend it. And once I extend it, this becomes an exterior angle. Do you see that? So this must be equal to that. So number 13, exterior angle is equal to opposite interior angle of a cyclic chord. Number 14. Now, number 14, for one of the properties of a cyclic chord is because, do you see we have a chord there, and this chord can produce, look at that chord, it produces different angles. So this angle here, let's mark it, this angle here will be equal to that angle. That's one of the properties. So we say what? Angles in the same segment. That's one of the ways of proving a cyclic quadrilateral. We're going to please watch out for our video that talks about how to answer Euclideans quickly. Now, number 15, or let's see the next letter. The next letter is P, parallel lines. Let's run quickly. P for parallel lines. Oh, that's from grade 8. Parallel lines. P, parallel lines. Parallel what? Lines. When two lines are parallel, what are the properties that we know about parallel lines? Properties that we know about parallel lines. There are three properties. We call it fun angles. I hope you remember. So this is number 15. So parallel lines, we talk about fun angles. Number 1, corresponding what? Angles. Number 16, co-interior angles. And we know co-interior angles are supplementary. And finally, number 17, we talk about what? Alternate angles being equal. Please be able, that's my co-interior. Okay, these are my alternate angles, this and this, because that forms a Z there. And definitely the two of them add up to what? 180. And you can actually see it here as well. Angles on a straight line. Beautiful. We go to T. Now, T is going to be made up of two sections as well. Let's quickly look at T. For T, we talk about triangles. Two things about T. So T talks about triangles. Quickly, just two things I would like us to deal with on triangles. So number 18 is that what? Sum of angles in a triangle is equal to 180 degrees. And number 19, exterior angle is equal to sum of opposite interior angles. Okay, so if this is, oh, I forgot to change this. 1 second. I'm going to have to quickly rewrite all of this, starting from number 18. Okay. We said number 18. Sum of angles in a triangle. That's very basic. And number 19. Exterior angle is equal to sum of opposite interior angles. If this is A and this is B, this becomes A plus B. Please, it's exterior because this line is extended. So we jump and we add the other two. Okay, that's very basic. Still on triangle, on letter T, we talk about tangents. Quickly, we have a circle and we have a tangent. Now, three things we are going to talk about here is number one, okay, I have a radius. So that angle there should be what? 90 degrees. That is radius, and that is 10. That's number one. Number two is our 10 chord theorem. So I'm going to create a quick chord. Okay, let me do it on the other side. I'm going to create a chord here. All right. And that should actually give me an angle there. Beautiful. That should give me an angle. So we're saying 10 chord. Please let's know how to read that 10 chord. The angle between the tangent and a chord is equal to the angle subtended by the chord in the alternate segment. And finally, on this, because I want to link all of them together, we have tangents drawn from common point. Okay. All right. That is not a tangent. That's a mathematical lie. Let's see if we can get that. Oh, lovely. Now look at this. I'm going to use a green thing to draw that. Beautiful. Beautiful. Oops. Let's see if we can get that right. There we go. All right. Let's try to pull that. Okay, that's not working. I'm gonna have to redraw it again. Oh, perfect. So what are we saying? We're saying this angle here is equal to that angle. Why? Tangents drawn from a common point are equal. So let's quickly put down number 20. Number 20. When we see a tangent, we're thinking about what? Tan chord theorem. Number 21. We're looking at tan. 1 second, just quickly need to undo something here. All right, number 20, we said tan chord. Number 21, tan is perpendicular to radius. And now, when I think about this, don't forget that once I think about the 90 degrees, before I go to that, I'm thinking of a right angle triangle, which is, I'm thinking of my Pythagoras, and I'm thinking of a SOHCAHTOA. And then number 23, tangents drawn from the same point. Tangents drawn from common point. Now look at what I'm going to pull out from here. I'm going to pull my 24 out. That gives me an isosceles triangle because this angle is equal to that angle. I must also think about angles opposite equal what? Sides. Okay, now we'll look at the last one. Let's look at the last one, which says plus 1. What is plus 1? Let's look at the last one. Plus 1 quickly. Now my plus 1 is just a way of bringing in theorem number 1. And what is theorem number 1 saying? Let's draw a quick circle. We have a line there, and we have a perpendicular bisector, a line that is drawn coming right from, or that passes through the center. So we have that and that, and the theorem says this will be equal to that. Please don't forget this name. It's called a perpendicular. Okay, I love to make it smaller so that it fits in. It's called a perpendicular bisector. So what are we saying? That would be number 25. Number 25, a line drawn from center, perpendicular to a chord, does what? Bisects the chord. And we must think of its converse quickly. A line drawn from center that bisects a chord is perpendicular. Now, that's not all. Number 27. Please look at this. This is going to help you to calculate all the time. That that gives us a right angle what? Triangle. So whenever I see this theorem, I think of or right angle what? Triangle. And what am I thinking of? I'm thinking of the theorem of Pythagoras, and I'm also thinking what? So SOHCAHTOA. Very, very important. Now, this is all grade 11. The next page is just our grade 12 theorems, where we have two theorems and we have triangles, similarity. Okay, we have two triangles there. So we're going to make this angle equal to that angle equal to that angle. So what do we know? Let's call this our 29. So this is similar triangles. We'll look for an acronym for that later on as we develop all of this. Number 28. If two triangles are similar, if two triangles are equiangular, and that is they're similar, then their sides are proportional. Check for our proofs on this. 29. Okay, so that's that. 29 is proportionality. Proportionality. So it's all about 30 things that I'm just to learn. Proportionality. Let's do this. Proportionality. Okay, or rather, let's do it on a fresh page because I want us to do two things here. Proportionality. Okay, we're looking for a triangle basically. We're looking for a triangle and two lines are parallel. Beautiful. So we're looking at proportionality, and if two lines are parallel, then we say A, B, C, D, and E. Okay, I just always forget to change that stuff. A, B, C, D, and E. Remember, that is proportional. Let me just delete this tiny little mark there. Let's see. Okay, great. So these two lines are parallel. Now, what is that telling us? This is going to be number 29. So the concept is to know that the sides are proportional. So if one line is drawn from the other, a line drawn from one side of a triangle parallel to the other side divides the third side in proportion. So we're saying AB over BC equals to AE, and I'm sure you know the different variations of this. Now, number 30, which is a variation from this, is called the midpoint theorem. It's a perfect combination of similarity and proportionality, but very, very specific. And what is the specificity here? This is equal to this, and this line is parallel to this line. So let's call this A, B, C, D, E. Take note, B becomes the midpoint. Automatically, to cause and effect, this one would also become what? The midpoint. So what are we saying here? We repeat that proportionality theorem, but number 30, right? So it's the midpoint theorem. B is the midpoint. So E will also be what? A midpoint. A line drawn from the midpoint of one that is parallel to the second will bisect the third in the midpoint. I'm just going to write the statement here. What does this tell me? This tells me that BE, please check this, all right, is exactly half of CD. So CD, or we can say CD, is 2BE. Just the same way that AC is 2AB, AD is 2AE. Please take note of all of this, that I am simply talking about a midpoint theorem, and I can also look at its converse. A line drawn from the midpoint. So a line drawn from the midpoint of one triangle parallel to the second side will pass through the midpoint of the third, and BE, see, this is a smaller part, is half of CD. This will also help us in analytical geometry. So those are 30 important concepts on all your theorems, and you need to know all of them. So our acronym, X Doctors in Cape Town +1, and then we add similarity, proportionality, and midpoint theorem. This is Krazifizix. Make it math simple and easy for you. You can email us, or you can send us a WhatsApp message, or follow our social media handles to see how we can help you further. Goodbye.